Can you hear me now? Oh, it is on. All right, that's better. Okay, so we are just about ready to get started. So thanks everyone, and thanks for taking the time to attend this session. Today, I'm Uni Ravindranathan, and I'm a program manager working on Visual Studio. My team, is responsible for building all of the tools for Windows 10 universal Windows app development. And today, I'm going to take the time to talk about .NET primarily and how it relates to building universal Windows apps using XAML. So just to summarize, just to again recap, we're going to primarily talk about .NET development in the context of XAML applications. I really don't know what the slide does, I guess. You guys can submit an evaluation form, but I'll skip past it. Okay, so I'm going to make an assumption. I'm going to assume that you've already had some experience building either a Windows 8.1 or a Windows Phone 8.1 .NET application, and primarily a XAML.NET application. And I'm going to go a little deeper into .NET today than stay at the high level. So if you have any questions at any point in time and you think I'm going too fast, please feel free to raise your hand and ask it, and I will try to clarify and slow down a little bit. My objective is that when you walk away from this session, you will have a better understanding of some of the key differences when it comes to how .NET works when it comes to Windows 10 universal apps in relation to how it used to work for Windows 8.1 or Windows Phone 8.1. So the key difference, and we're probably going to spend most of the time talking about today, is .NET Native. But before I describe some of the benefits and what it is, I'm just curious, how many of you have heard of .NET Native before? Well, that's actually a pretty good chunk of the audience. So just for the remainder of the folks, let me take a couple of minutes to recap what is .NET Native. It's our next generation of compiler technologies for .NET that allows us to compile .NET applications down to the actual bits, be that x86 or x64 or ARM, in the cloud. It allows us to provide a converged, consistent set of experiences across all devices that run Windows 10. And it also allows us to use some of the great work we have done in our C++ technologies in our backend to bring that to a .NET developer. We've done a lot of work to make sure that the optimizations that we do for your C++ code are actually pretty good. And this is an opportunity where we are bringing that to you as well, the .NET developer. So you might ask the question, why .NET Native? And there are multiple facets of this particular question that I'm going to try to sort of address here. The very first thing is mobile apps today and the apps that you would particularly build for Windows 10, universal Windows apps for Windows 10. They have a certain set of requirements that's different than what you would have expected from a typical Win32 style desktop application, let's say a WPF application or something like that. Your users, the users of your application, expect something from these apps, and some of them are fast startup time. If your app doesn't really start up within a particular duration, take your pick, let's say 500 milliseconds, your user is going to walk away. And so with .NET Native, we have the technology, and we're bringing it to you to help improve startup times with hopefully very little work on your end. The reason why we are able to achieve a fast app startup time is because we are trying to avoid JIT completely. So just-in-time compilation will not happen on a device if you're using .NET Native. And that's one of the reasons why the apps are faster, and they also start up faster as well. Now, the added benefit of not having JIT is that you're doing less work on the CPU, right? Everything is happening in the cloud before that consumer even gets the app. That has the added benefit that, because the CPU is getting used less, there's a little bit more savings in terms of battery life. So the battery life is also getting a boost because of .NET Native in an orthogonal way. In our labs, we have been using a number of the apps that you folks have built today just to test out the technology and try to see how it works for existing apps. We have noticed up to 60% of savings when you're doing a cold startup. And of course, these numbers will really vary. If you take your Hello World application that doesn't really do much, you probably won't see as big a win. But the more complex the app gets and the more functionality it has, the better the savings there can potentially be by using .NET Native. And then for warm startup, we are seeing improvements somewhere in the range of 40% as well. So again, I want to be caveating this by clearly saying it depends on the kind of application. And the more complex the app, the better the savings there will be. Another important characteristic of these mobile apps is they should not be using a lot of memory. The working set requirements, like especially in devices that have very little RAM, is actually pretty stringent. And so with .NET Native, we are also able to address this problem to a certain extent. The optimizations we do on the compiler side to take out types and properties and events that you really probably don't even need for the functionality of application means your working set is probably going to be better at the end of the day by using .NET Native. Again, in our labs, we have been doing tests against real-world apps, and we have seen savings up to 30% on this front as well. To summarize, .NET Native helps improve app performance in a number of ways. Another big reason, and you have been hearing about this throughout this build, is adaptive apps. Adaptive apps allow us to sort of, so Windows is going to sort of start bringing innovations in terms of new APIs and functionality to you very quickly. You as a developer have to start thinking about how you manage this in terms of, let's say you get an SDK every few months. How do you write an app that leverages functionality in this SDK in a light-up fashion, where you sort of like go and adapt your application to provide the users of your application better functionality as newer and newer APIs are available? Similarly, not all APIs that Windows provides are going to be available on all devices. There are going to be device-specific APIs that are either available only on the desktop or mobile. How do you think about lighting up functionality on an application for an application that only runs on such a device? Our answer to that is adaptive code. The screenshot over there, my apologies if it's not really clear at the back of the room. It's the pattern that you would kind of use a lot when you're building a universal Windows app, where you will sort of check for the presence of an API, and then you will execute that line of code when that API doesn't really, when you can be confident that the API does exist. The problem with this line of code is, historically, if you talk about .NET apps running on top of Windows 8.1, this particular line of code would have crashed your application. And the reason for that is we would JIT this code, which is just-in-time compile this code on the device. The particular type would not exist, and you would either get a type load exception or a method not found exception, and so on and so forth. With .NET Native, because we are avoiding JIT completely, you're able to write this line of code and execute it on the target device without crashing. So what this allows you to do is use a very common coding pattern in Windows 10 and use it in a very natural way. If you didn't have this capability, you would have to do some advanced refactoring operations, hide this all behind interfaces, call those interfaces, and so on and so forth. This is a very natural way of writing code. And with .NET Native, we bring this capability to the .NET developer as well. And finally, faster cadence. This is a problem that we have been struggling for some time now. Historically, we have had a very tight coupling with Windows and .NET. Like, if you think about Windows 8.0, the first version of Windows 8 that came out, we had a set of APIs, and we sort of bunched them together into a reference set called .NET Core 4.5, and that's the one that we are using for building a Windows 8 app. With Windows 8.1, we got a bunch of feedback from folks, and we added a bunch of new APIs. We sort of revisioned that to call Windows 4.5.1. The problem with these monolithic references that you sort of add to your project is we are tied to sort of the Windows update cadence. Like, it's very hard for us to innovate on the .NET side, be that in terms of like libraries and functionality, or even in terms of Visual Studio debugging experiences, because we really expect the operating system to have an update cycle before those APIs can be available to you. That's one of the things that we want to sort of try to sort of rethink and see how we can do better. So with .NET Native, because you're sort of compiling statically linking in the entire framework into your application, what that really means is you kind of control what your application references, and you control what sort of functionality do you want to bring to the consumer. You don't really have to wait for Windows Update to push out a new version of .NET before you can sort of take advantage of that. So we expect Universal Windows apps to sort of take benefit of this feature and get more and more functionality, either via NuGet, that we will sort of publish more and more libraries and functionality to the user without actually waiting for Windows Update. And of course, a Windows Update will never break your application because your application is really self-contained. It contains all of the .NET code that it needs to run and doesn't depend on a system-wide .NET and an update event for that. So one thing, like, did you guys know that we have been actually pushing out .NET binaries to your devices, over the past, couple of months, or actually year? The apps over here, these are some of the apps that we have already pushed out to you guys by running with .NET Native in the cloud. So for these apps, what we have done is we have sort of taken the apps from the store, run the .NET Native toolchain, and then pushed it to you guys. So you're actually using these apps today. For example, the calendar on Windows Phone is already a .NET Native app. The reason why we did this is we wanted to get some more confidence around this particular scenario, where we wanted to make sure that apps don't really break when we sort of transform them from MSIL to .NET Native. So this is a technology that we've been working for a while, and we have already baked to a certain extent, and now we are ready to bring it to the vast majority of developers out there. Which leads us to this statement. All Universal Windows 10 .NET apps that you will deliver to your client via the Windows Store, or even via an enterprise sideload scenario, will have to be compiled with .NET Native. So it becomes really commonplace for everyone out there, and it's important to understand how you should approach this and how you should think about .NET Native in that context. So now let's take a moment to think about the developer workflow and how this developer workflow changes slightly when you bring .NET Native into the mix. Just like before, you can continue to write your code in your favorite .NET language, be that C# or VB. We support .NET Native for both of those languages, so that really doesn't change. Similarly, you would, of course, debug and code your application using the debug configuration in Visual Studio. That doesn't really change either. You continue to sort of push out your apps to multiple devices, be that phones or tablets or PCs. Nothing really changes from that perspective as well. What really is an important difference between Windows 8.1 and Windows 10 Universal Apps Development is the release configuration. Because when you build an application with the release configuration in Visual Studio, by default, we are turning on .NET Native as the technology that builds the particular code base. And it's really important, and this is where I'm going to keep repeating throughout the session today, it's really important that you test your application frequently and periodically under release. We'll talk about how this changes in a second when we look at what's going on behind the scenes. Yes, sir? Yeah, let me repeat the question. Great question, and I'll answer that question when I take a look. The question is, you kind of lied when you said, your app is not going to, have any JIT crashes when you're doing debug. How do you actually handle that when you're testing this application on a device when an API is not present? I'll answer that question for sure. Creating packages in the store is the same. The workflow in Visual Studio is identical. There are some differences in the packages that you build as debug and release, and we'll articulate that as well. But as a developer, hopefully that is extremely transparent to you. Now here's where the interesting part comes online. When you upload your packages to the store, they are uploaded as MSIL. And behind the scenes, in the cloud, we will run .NET Native on your store submitted packages to convert them to .NET Native before they are delivered to the client. Now, there are a few reasons why we run .NET Native in the cloud as opposed to you submitting .NET Native packages directly. One of the primary reasons is, should there be a security vulnerability? Or should there be better optimization technologies that we want to sort of innovate on? Or should there be compatible changes we want to make? We can recompile your app and submit it down to the client without you even knowing about it. Now, of course, you should be assured that we'll guarantee compatibility in this case and won't break your app. But having the ability to compile and then sort of target even newer processor architectures is actually really important, and this is one of the reasons why we sort of do cloud compilation on the .NET native side instead of you submitting those packages to the store. And like we said, when your consumer downloads those packages, they are .NET native compiled, and they are not MSIL anymore. So with that said, let's switch over to Visual Studio and try to answer the question that you just asked in addition to more. So, all right. Is the text very visible at the back of the room? No? Oops, this is always a problem. Because if I make it too big, Visual Studio's UI starts looking not so good. But I'll try. Fun second. Well, because I'm not really going to use the text editor, I'm actually going to use the rest of the Visual Studio user experience, but I'll improve both. I'm actually going to use everything outside of the text editor more than anything else, but I'll fix them both. So text editor goes to 16, but more importantly, the environment, where is that? There we go. That goes to, let's say, 14. Is that better? OK. Thank you. I'm not going to write in too much code, so don't worry about that. So let's take a quick tour of how .NET Native comes into the picture in Visual Studio. Over here, debug configuration, release configuration remains the same. You must be very familiar with these concepts. When you upload your app to the store, you have to build as release. We continue to support both of those configurations. If you look at the target architectures, any .NET developer will immediately jump and say, where is my any CPU? And we'll talk about that in a second. But generally, you can build your application as x86, ARM, or x64. And then as new processor architectures come online, they'll be added onto this list as well. Nothing really changes from that perspective. Let's take a quick look at the project properties themselves, which is the more interesting part. Over the last couple of days, we have been talking about adaptive apps and how you think about getting access to new APIs. To get access to new WinRT APIs, you will need to acquire a new version of Windows SDK and then target it via this dropdown. We have had multiple sessions on universal apps where people have talked about targeting, and I'm not going to go to the details. But assume like you download a new SDK and a new entry shows down here, and you just continue to sort of like just pick that up, and you get access to the APIs that particular SDK exposes. The min version dropdown allows you to sort of specify the universal Windows platform that you require for the application to run. If you specify a particular version here, you can be guaranteed that the application will not be offered to a device that's running a version that's older than what you specified. So this allows you to constrain this min and max values, as we call it, allow you to constrain the range of Windows devices that you want to target. Now, it's in your best interest that you target the widest possible range of devices, but at the same time, you also have to be realistic about the test matrix and how you want to think about it. So that's really a choice that you can make. I'm not going to go too much into the details here because we have discussed this in prior sessions. But the interesting part really is in the build options. And like we discussed, there is debug and release. But if you take a look at the debug configuration, there is a new checkbox here, compiled with .NET Native toolchain. And that checkbox is turned off by default. By the way, if you have used a prior CTP of the .NET Native tools, you would have had a slightly different workflow. It's actually much better integrated now. You really don't have to install anything separate. It's all integrated into this one checkbox. And this is pretty much the only checkbox that you have to ever deal with for the most part. Now, if I go ahead and switch the configuration to release, that's when you'll see that the checkbox is on. And what that really means is when I'm building my app when I'm building under the release configuration, I'm going to compile with the .NET Native toolchain. So that's where most of the work is happening relative to what the big difference is between Windows 8 and Windows 10. So let's go ahead and build debug first and take a look at what's going on behind the scenes. Just wait for a quick second. The app builds and runs. We are not going to go too much into the debugging experience, though off the bat you will see some of the new experiences like the UI debugging tools and things like that. I have a session dedicated to the Visual Studio goodness tomorrow, so I'm not going to go too much into any of those experiences today. So let's stop debugging and look at what actually happened behind the scenes. That's where most of the interesting work is. So if I go ahead and open my x86 debug package and crack open the manifest, the very first thing you will notice is, oops, did I get it right? Oh, sorry, I got the wrong guy. If I open up the manifest, that text is visible back there, right? OK, great. So the first thing you will notice is we have transformed the manifest slightly between what you have in your project and what's generated. We have generated an entry called package dependency. And what this is we are basically taking a dependency on a core CLR framework package. So to put this in other ways, your application is running against a sort of like a private version of the core CLR. When you actually deploy this application to a device, we are going to push the core CLR to the device before the application actually executes. So let me state this in another way. Core CLR, we think, is primarily a debugging scenario. And hence, it doesn't make sense for Windows devices generally, where space, disk footprint, and things like that are important, to carry the core CLR with them. So we do have to push the core CLR as a part of the Visual Studio debugging experiences, and that's what this is. Another way to think about this is we will start bringing more and more changes to the core CLR in terms of Visual Studio debugging experiences much more rapidly, because now we are just deploying core CLR to any device that we want to debug the app against. The other transformation that's worth calling out is we have changed your executable slightly to actually use a shadow executable. What the shadow executable does is all it does is a very thin layer that boots up the core CLR and then your code that goes with it. Nothing really changes from your perspective. You probably won't even notice this once I describe what's going on. Your debugging experience and development experience remains the same. Everything, there should be no difference at all. Just that I wanted to show you how core CLR comes into the picture. Now, you asked me a good question, like how do you prevent JIT failures from happening? Because what's happening is we are taking this code and executing on a mobile device or a desktop device, and that particular API doesn't exist on the desktop device. The way we do that is the Win metadata folder that exists here. What we do is we push what we call a union metadata file to every device that you're currently debugging. Think about this union metadata file as containing all of the WinRT types that you ever could potentially have access to in your application. So this particular metadata file contains all of the types and properties that could ever exist at that point in time as you're developing your application. By pushing this file over to the device, the JIT is actually going to use this metadata to resolve itself, and it's going to prevent the crash from happening. At the same time, if you do an adaptive check, you say, hey, does this particular if something exists, that check will still return the right valid value, and you'll be able to get the exact same functionality. So with this particular metadata file, we are preventing both the JIT failure, as well as we are actually giving you the right behavior from a debugger perspective, so you can correctly diagnose issues and functionality in your application. The other thing that's really important, worth calling out, is you'll see we copied a lot of references into your package, and that's intentional. Like I said before, when we talk about .NET Native, you're sort of statically linking in your entire framework into your application, very similar to a C++ application. So when you actually think about uploading this app to the store has no idea as to what you built against. And it's really important for us to have a contained package that contains all of the metadata that you upload to the store. That's what this package is, and it contains every single framework reference that you could potentially ever use in your application. It also means we can ship newer and newer versions of the framework packages and DLLs, and you can continue to use them without having to wait for a whole Windows update cycle, the whole faster cadence thing that we just talked about at the beginning of the presentation. So that's how the debug workflow works. Before I switch to release, any questions? Yes? Yeah, so the question is this going to increase the size of the application? And the answer is yes, but we have some techniques to avoid that. When I do the release configuration, you will see an increase, and I'll talk about what we are going to do to make sure that we don't have that problem. So yes, you're right. You're statically linking in, but at the same time, we have ways to avoid that problem as well. Yes? So the question is, why would I ever want to do this, where I'm doing something that's not very close to the release behavior. So one thing is we have done a lot of work to make sure that that onus is on us. Your debug behavior and release behavior, it's in our best interest that they are close to each other. And we will not guarantee it, but we've done a lot of work to make sure that that's the case. The thing why you don't want to use .NET Native all the time is that toolchain takes a while to run. And you'll see that when I'm doing the release build. You don't want to be sort of like taking that pain every time you're sort of debugging your application. You want to be productive, because that's the promise of .NET. A quick build, run. We want to sort of like make sure that that productivity is retained. But at the same time, we also realize that you're actually changing the bits under you. And hence, it's important that you inculcate this practice of frequently testing release bits. But at the same time, you absolutely should feel confident that you're testing mostly against debug bits. Otherwise, your productivity is hampered. And that's a promise we want to give you from that perspective. OK. So let's go ahead and switch to release and build and run this application. Like I said, it's going to take a while. It's going to take about 45 to 50 seconds. And that's one of the things that is really important for us to go fix. And we are working on some of these solutions. But at the same time, it's actually doing a lot of work behind the scenes. So you should expect this to be absolutely slower than a debug build for sure, right? So that's work we are doing. But at the same time, currently, this is going to take about 45 to 50 seconds. But while the build is happening, it's already starting to produce some artifacts, and we can go take a look at those. So let's go ahead and open the release folder now and see what's going on. Let's first open the manifest file. And you'll notice that now there are no more changes. Like if you look at the dependencies section, it's empty, and it has no dependencies on any core CLR framework package. Your manifest is now exactly the same as you had specified in your source project, just transformed to add version information and things like that. It's also worth calling out at the bottom of the manifest, we have added some extra metadata. This has no impact on the functionality of application. That basically tells what the version of the tool chain is that you have compiled your app with. What this allows us to do is, in the cloud, match up the exact same tool chain and make sure that the bits that we generate in the cloud are identical to what you actually tested with. It also allows us to ship newer and newer versions of the toolchain with better improvements and optimizations. And we can do that all out of band without actually having to wait for some synchronization between Windows and Visual Studio and the .NET team. So there is work we have done there as well. So let's ignore the debugging experience because it's very similar. It's more interesting to look at some of the other artifacts as well. So if you look at the Apex folder, it contains some more DLLs than what's the final design. We are not done with this. We are not done with the RTM of this product. So I'm going to just switch over to an Apex that I cleaned up manually, just so you can get an idea of what it looks like. And here is what it is. It is actually extremely clean and simple. There is nothing, no magic here at all. There's the manifest. But here's the large DLL that you just talked about. It's about 8 megs. And then there is a very thin executable, as well as a couple of very small CLR runtimes baked into the Apex package. Now, you might be worried about the 8 MB statically linked library that we generated. And I'll talk about what we are doing to mitigate that. But that's one of the artifacts that we produce today when you run .NET Native toolchain. I'll talk about some of the mitigations we plan when we get to that scenario in a second. And everything else is actually exactly what you would expect in an Apex package. Any questions so far? Yes, sir.
Since you can rebuild my code, do I get notified with that? And how do I know which of the builds that the user was running when they got a bug?
Yeah, great. So you're talking about what we call post-mortem debugging, like the user got a crash, and I'll talk about that too. Absolutely, I got that. OK, so let's switch back to slides for a second before we come back to showing another part of the workflow and do a quick summary, because we talked about a lot of things. You'd continue to build your application in your language of your choice, C# or VB, no problem. You'll build and run your application as debug. And the big differences here are you're using the core CLR for debugging your application. We do have a metadata file that we generate, and we keep it updated with all SDKs that you could ever install on the machine, so that when you're testing your application, you don't run into any JIT failures. And then, of course, we'd copy all of the .NET references into your package as well. When you're doing testing your application, that's when you're running with the .NET Native toolchain. The packages that you submit to the store There is some, some knowledge that you need to have here, which we'll talk about in a later part of the section. But generally, your workflow is the same. You'd continue to upload the Apex upload files to the store that contain various architectures, and you would continue to sideload if you're an enterprise customer. And as you guys heard, we did a lot of work to make sideloading a lot more easier in Windows 10. You'd continue to use the Apex package to sideload to the right device in an enterprise scenario. And the rest of that we already talked about. Like the store compiles the Apex with the .NET native toolchain before it sends it down to the client. The only thing I wanted to call out from the perspective of the developer workflow that you should be aware of is in Visual Studio, in our packaging wizard, you can specify a version specific to your policy of the company that you're working for. The one change that we're making in Windows 10 is you can no longer use the revision field. The revision field, which is the one that's highlighted on the screen, is going to be blocked from being used. And the reason for that is, like we said, the store is going to compile other revisions without you probably not knowing, for extreme cases, let's say, not in the more common scenario. And we want to have some capability to version that package that your client gets from the store. So you can continue to use the first three fields to your liking. Just don't touch the fourth field when you upload it to the store, because that's going to be reserved by the store. Yes, sir? Yeah, you can use, so when you say auto increment, we are now just going one field to the left, and we're going to auto increment the third field instead of the fourth field. So we've done that work. And let me just repeat the question. Can you use asterisk for the third field now? Yes, you can. Will that include? That's a good question. I don't know. So the question is, will we automatically stamp that with the date time of the compile step? I actually don't know the answer to that. Maybe I'll follow up on that particular question offline. But I'm sure that you can auto-increment that. I just don't know what the characteristics of the default value are. And then, like we said, when your consumer downloads the device, they will get .NET native packages. Yes, sir? The one that you're not supposed to touch? You put 0 there and you're done. Yeah, I mean, I don't know I hope we don't have that many of them, but I don't know the max value, to be honest with you. The question is, what's the max value of that field? And my answer is, I don't know, but I'll definitely, follow up on that question as well. Okay. Now you might say, I love my NeCPU, and that's a valid like I've been following on Twitter feedback and things like that, and this comes up. And I acknowledge that. This is feedback that we're looking from you guys. If you think this is a significant hindrance to your workflow, we'd love to hear your feedback and do better. That's certainly something that we're on the watch for. But our rationale for this is twofold. One of that is there's a lot of technical complexity in doing that. But that aside, like I said, it's really important that with .NET Native, you test your application against the real device on the real architecture, as opposed to any CPU which sort of fakes with a preferred 32-bit flag or something like that. So that's one of the reasons why we wanted to sort of go out there without any CPU, see what people think, and then come back and sort of like, if that's a significant workflow blocker, we can sort of look into addressing that as well. Now, one thing I want to call out is, if you're a library author, and there are some of you out there, for you, the workflow doesn't really change. You can continue to ship your NeCPU binary, because it's up to the developer who consumes the binary to sort of go compile that down to the specific architecture. So from a library author perspective, you can continue to do business as usual and continue to ship your NeCPU binaries out there. It's on the developer who's consuming that this onus is on. We talked a little bit about packaging, but I wanted to sort of, there are a couple of key gotchas that you should be aware of, and I wanted to throw it out there. One is debug packages. You can never submit them to the store, and that's always been the case, because Windows App Certification Kit will fail those. The debug Apex packages are compiled with MSIL. There is no changes. That's the case. It was there before, and it's the same today. We don't always also generate an Apex upload file, because we want to make sure that you don't accidentally go submit. There is no store submission scenario on a debug workflow, and hence there is no reason why we should generate an Apex upload. Release is where the interesting bits happen. When you build a release.NET Native package using our packaging wizard, we will generate actually both apexes. We'll generate an .NET Native apex and MSIL apex. The reason why we do both is we think enterprise sideloading is a common scenario. And please do not sideload an MSIL Apex package. Always sideload a .NET Native Apex package, because things like adaptive code will crash if you sideloaded the MSIL Apex package to devices that don't have APIs. When you're uploading to the store, we do all the work to make sure that the package that you upload to the store, the Apex upload file, contains the right bits, which is the MSIL Apex package. So we've done all this work to make sure that we put you on the right path. But it's really important to keep in mind that you shouldn't accidentally go and sideload an MSIL Apex package in an enterprise scenario. So you should be careful about that. Any questions? OK. So here's another topic that I wanted to throw out there. That sort of is kind of important. Runtime directives. What are runtime directives? Runtime directives are sort of hints to our .NET Native toolchain to sort of change the optimization strategy a little bit. By default, 90% of you out there probably don't have to worry about this. We do the right thing by default, where our policy is conservative. What we mean by that is, by default, we'll retain all of the types and properties and metadata, and hence you might likely see slightly larger binaries. But that's probably the right balance for most of you users out there. There are a few of you who will probably want to eke out that every last bit of performance in your application, and that's where you'll need to pay attention to this particular workflow, which I'll show in a quick second. You use runtime directives to declare what types you want us to keep, and what types and properties and namespaces and things like that you want us to drop. You have the flexibility to sort of say drop everything, in which case hopefully your app is not really functional at that point. But you can also specifically tell us what specific namespaces and types to keep. Let's say you're using reflection, a string-based API. How do we know what to keep and what to throw? If you want to sort of tune the optimizer all the way through so that you want to use advanced reflection for certain scenarios, you will have to worry about this and make changes. The one thing I wanted to call out is .NET Native does support reflection. That's not really the issue. The issue here is when we run the optimizer, we need to make sure that we retain your metadata so your reflection can succeed. One important call out for control library authors, make sure that your control library contains an embedded resource that specifies this metadata. Make sure that it contains an rd.xml that can have a conservative policy, that's fine, but it needs to be there because your user could be actually a guy who wants to sort of get real performance out of the application. They could strip down everything accidentally if you don't actually, and they don't know the details of your library, what your library is doing. So if your library is doing advanced reflection and things like that, you should give us this hint so that we can do the right thing. Again, like I said, if you think that this thing is a little bit more complex, that's fine. Most of you probably don't have to deal with it. Let me show a quick demo of what kind of wins you can get if you sort of care about it. So let me go switch back to Visual Studio and take a look at a sample project. So in this particular project, I have a control library and an application. It's a kind of a fake scenario just to sort of make the point. The control library has two controls, a data grid and a chart. In my application, I only care about using the chart control. I could never care less about the data grid. That's the scenario I'm trying to sort of paint out there. By default, if I built and run this application, remember what I said? We use a very conservative policy, and we retain all of the metadata. So if I go back to my application, and I'm not going to spend the time to build this again with .NET Native. I already have a pre-built package. So here's my pre-built package, and here's the DLL that I get as a result of that package that I just built. It's about, just like before, it's about 8 megs. Now, let's say I really care about this scenario, and I want to sort of make it smaller and monkey with the setting more than what I really care about the perf here. So let's go ahead and take a look at this file, default.rd.xml, which is something we add to your every project out there. If I go ahead and open it, you will see that by default, we have an entry in here, which is what I said, our conservative policy. Keep everything, retain everything, don't change. Just keep all metadata and reflection information and implementation around. You can change this. So let's say I go and comment this out and comment this other line back in. What this is now we are telling the .NET Native optimizer to sort of only retain metadata about the chart control and implementation and not worry about the data grid at all. If I build and run this application with the .NET Native toolchain and take a look at what I get as a result of that, you'll see that's about a meg less. Now, how can one type result in a 1 meg saving? That's because you changed the policy pretty aggressively. You changed from retain everything to just retain the chart control. Now, I can sort of fine-tune this further and further, but you can get the point. Like you could choose to sort of tune the optimizer if you wanted to, but for the most part, it should do the right thing out of the box. Any questions? OK. So what are some of the best practices that you should follow if you're building a .NET Native application, or in particular a Universal Windows application, because all of them are going to be .NET Native? Primarily develop your application using debug, but make sure that you periodically test your application using release as well. Don't defer the whole thing to the very end, because then it gets a little bit more tricky. Periodically keep testing your application under release. Now, like I said, we have done a lot of work to make sure that the difference in behavior between debug and release is not much. But just in case you do run into a problem, one way that you can probably make OK, the first thing is you should send us email. So we'd love to hear your feedback and make sure that we take a look and make sure that you don't have to worry about it and it's our problem. But just in case you are curious and sort of want to investigate this, one technique could be to turn on .NET Native in a debug build using the checkbox that I showed at the beginning of the presentation. That'll probably give you some more information that you can use to better diagnose such issues. But we really hope you don't have to do this. Submitting an Apex to the store, the most common scenario is to use the Apex upload file. We do all of the right things for you. But just in case you're interested in submitting individual Apexes to the store, which is also, many people do that as well, you should definitely make sure that you turn off the flag for building with .NET Native. Create a custom configuration and turn off this flag, and then submit the MSIL package to the store. Like I said, there is a bunch of work we're already starting to do on the team between now and RTM to improve the experience, primarily around the throughput of the build, as well as incremental build. Some of this we'll get to very soon. Some of this we'll keep working on and improving and delivering to you as quickly as we can. The way we're going to reduce the size of the DLL that you saw, the 8 megs, is we are taking some common parts of the framework that everyone is going to likely use and refactor that into a framework package. So your application will contain libraries that we don't think that are as common, statically linked in, and it'll also contain a reference to a framework package that contains the more common functionality. So that way we'll be able to make sure that your application doesn't contain the entire framework statically linked in. It's a balance between the most common use cases, and we have a lot of data on that, versus what you specifically need and things like that. So that's by using that technique, we'll be able to control the size of the DLL and the package. Yeah, so the question is, will you run into versioning issues with what you referenced at the beginning of the presentation? No, because the way we will do this, how should I say this? The reason why you run into versioning primarily is because we are sort of tied into the Windows update cadence. In this case, it's a framework package. It can be updated in the store at any point. As long as that framework package keeps growing, your app just downloads a newer version of the framework package, and it's done. Versus an older version, framework packages are side by side in the store, right? So you'll download the right version of the framework package depending upon what references you have in your project at compile time. And that way, we'll be able to make sure that different apps that have different requirements continue to get the right bits that they need to execute the functionality. There are a few VS experiences. Did I cover this one? Oh, that one. Postmortem debugging. So this is the one that the gentleman over there was asking. This is where your app crashes on a device that you don't own. And how do you actually debug this sort of a crash, right? You get a PDB, or you get a crash dump. What do you do with it? The best practices, of course, apply. Maintain forks of your source code, right? That's the way you would, independent of .NET Native, you really need to maintain a matching PDB and source code combination. So keep that in mind. That doesn't really change. We are working with the store team to make the PDBs available to you. So you'll be able to go to the developer portal and download the PDBs. And that's the way you would sort of debug the application. So you would load the PDBs from the ones that you downloaded from the store, and then a fork of your source code using the two, you should be able to debug, or at least get a call stack from the customer application.
So if I have 5 versions of my app over time, there'll be 5 different versions.
Yes, that's correct. The question is, if you have 5 versions of your app over time, will there be 5 PDBs, correct? And that's the case today as well. Like if you have 5 versions of your application, if you want to get the most, the best debugging experience, you should have 5 versions of your PDBs as well. Now, if your source code hasn't changed significantly, you may get lucky, but for the most part, you do have 5 PDBs even today. Yes, sir.
So when you automatically rebuild it, you're going to put another set of PDBs down there for me to go get?
Yes, the question is so the question is, if we automatically do a rebuild in the cloud for you, will we get a different set of PDBs? The answer is yes. We don't think this automatic rebuild is that common a scenario. We just have that mechanism in place to sort of, address some eventualities. But yes, we will get you PDBs for that particular build. That's a good question. Will you get notified when we do an auto rebuild? I don't have a good answer to that. I hope so. .NET Native has some VS integration backlog that we haven't really addressed. The one that you'll probably care about most is edit and continue. You do have to do and by the way, we just added edit and continue for C++ when, like in VS 2015 or something like that. Edit and continue doesn't work for .NET Native apps. It does work for debug when you're doing core CLR. So that's what I said. You should primarily use your debug loop using core CLR because that's going to be the best, most productive environment. But we don't support edit and continue for .NET Native. Things like obfuscation and IntelliTrace and just my code also don't work. But all of these, of course, work just fine for a debug build. .NET Framework evolution. This is a question that came up like a couple times earlier this week. Like, how do we think about bringing innovation to you quickly? Now, the way to think about this is the set of APIs that we're giving you for Windows 10 is the same as the set of APIs that we gave you for Windows 8.1, with one important clarification. All APIs will work on all devices, which means WCF, which is a question that we get all the time, Windows Communication Foundation, works on Windows Phone as well, right? So, well, I like that. So that's one clarification. But that's not the whole story, because that's the story that we're going to give you out of the box. In parallel, we are working to sort of deliver newer and newer libraries via NuGet going forward. So we'll bring new implementations of newer features and functionality that you guys are asking via NuGet. And you'll already see some of the examples. Like if you take a look at the default project templates in Visual Studio, we already have first few examples where we have system numerics, for example, included in your default template. We'll start adding more and more surface area to your projects based on what you guys need, over time as NuGet deliverables, and that allows us to be agile and quick and get things out to you quickly. There's one last point I wanted to make, which is about consuming libraries, and this is a question we get a lot when our internal teams are building apps. What's the story for portable class libraries, and how do you think about consuming native references in your application? Portable class libraries, we are working to add Windows 10 support, of course, but keep in mind that portable class libraries that were built for Windows 8 and Windows 8.1 and Windows Phone 8.1 should just work as is. Like, assuming so one important caveat is, with Windows 8.1 and Windows 8 Phone 8.1, we added support for WinRT to a portable class library. So if you go and call into a WinRT API that doesn't exist on a device, now that is not something much we can do about, but that should be a very isolated, rare case. So for the most part, your existing PCL should just work in your Windows 10 application. .NET native references, you should be able to add either an existing Windows 8.1 or a Windows Phone 8.1 native reference just to a managed application and be able to use it. The only gotcha is you should also add a reference to the Visual Studio 2013 CRT to your application in addition to the native reference, because keep in mind that these are DLLs that were compiled with a different CRT, right? So you do need to add a reference to the CRT. The good news is you can continue to sort of use both CRT references together. So you can have an app that's using a Windows 8.1 component with the Visual Studio 2013 CRT. And then the same app can also use a Windows Universal component built with the Visual Studio 2015 CRT. So that should all be pretty seamless. Just keep that in mind when you're adding references. Like I said, if there's one call to action that I would like to sort of hear feedback, if you take an app, make it a universal Windows app, and then if you're seeing a difference in behavior between debug and release, we would love to hear from you ASAP so we can go and address those. Our goal is to make it such that there should be no differences at all. So please do let us know. And these are the two aliases you can use, .native@microsoft.com. Please do send your mail with hopefully a reproduction of the problem, and we'll take an urgent look at that. All of the stuff that we talked about, specifically around runtime directives, is all documented. Like I said, we focus primarily on .NET Native today. There is another part of Visual Studio specifically around rich XAML tooling we're building for universal Windows apps. My session tomorrow will go deep into that. We just don't have enough time to touch on that level of detail today. I'll take you through a tour of all of the unique experiences for universal Windows apps in Visual Studio 2015 tomorrow at around noon or something like that. There is a number of sessions we did, like the lap around .NET should give you the big picture of all of the things that we're doing in .NET. That's a good session to take a look at. But these are some of the resources that you can also sort of use to learn more about this experience. With that said, I'll open up the floor to questions. But more importantly, do take the time to evaluate the session. Your feedback is really useful. We really appreciate the time that you took to come, like 6 p.m. today or something like that. But again, thank you, and let me know if you have any questions.